Happy morning, children. Today we are going to see about the first chapter in science, that is chemical reactions and equations, right? So this is the first chapter in science, very interesting chapter, the basic of chemistry we will know here, right? So in this chapter we are going to know about what is a chemical reaction, what is the equation, how to balance the equation, types of reactions, reduction and oxidation reactions, corrosion and rancidity. These are the topics covered in this lesson, right? So in this sector we will see only two things, that is what is a chemical reaction, what is the equation, that we will see now, right? So what is a chemical reaction? It's nothing but interaction of chemicals to form a new compound or rearrangement of atoms or molecules to form a new arrangement. So several definitions can be given to chemical reactions. So simply we can understand in such a way that interaction of chemicals to form a new compound, that is called a chemical reaction, right? Okay, I'll write here interaction of chemicals to form a new compound, product or chemical, whatever it may be. So this is a chemical reaction, right? So these chemical reactions are accompanied by several changes. A chemical reaction can be defined as a interaction of chemicals to form a new product or rearrangement of atoms or molecules to form a new compound, right? So usually these chemical reactions will be accompanied by either change in color or change in state, either solid or liquid or gas. There will be change in phase and change in temperature. Exothermic and endothermic reactions are there, and gas may be evolved, precipitation may be formed. So this is a chemical reaction. Most of the chemical reactions are irreversible, and reversible reactions also are there under drastic conditions. So this is a chemical reaction, right? So chemical reactions, we know what is a chemical reaction now. Then what is an equation? We will take an example. So a simple chemical reaction here, carbon combines with oxygen to form carbon dioxide, right? This is a chemical reaction. So this is such a lengthy write-up, so that we are giving the entire thing what is happening inside, right? So this can be symbolized and mathematically expressed as C plus O2 gives CO2. That is symbol of carbon, symbol of oxygen, symbol of carbon dioxide, right? This is carbon dioxide, formation of carbon dioxide. And in equation, this is called equation, and the physical state of the element can be mentioned. Carbon is in solid state, oxygen is in gaseous state, and carbon dioxide is also in gaseous state. So we can define the equation as symbolized and mathematical expression of chemical reaction, right? And the more information can also be observed, can be known from the chemical reaction rather than writing the entire concept, right? So instead of writing this lengthy thing, we can simply write carbon plus oxygen reacts together to give carbon dioxide. So this is called the chemical equation. So what is a chemical reaction? Interaction of chemicals to form new product or compound or chemical is called a chemical reaction, that may be accompanied with either change of color, change of state, change in temperature, either gas may be evolved, precipitate may be formed. And the mathematical and symbolical representation of chemical reaction is called a chemical equation. Let us have another example here. So hydrogen plus oxygen gives water. This is also a chemical reaction, right? Last we have seen about chemical reactions. What is chemical reaction? What is an equation? We can see that one. Now we can see how to balance a chemical reaction or chemical equation, right? First of all, why should we balance a chemical reaction or chemical equation? Because law of conservation of mass is a basic law of science, right? Whatever input we are giving, that should be the output, right? So what is law of conservation of mass? Law of conservation of mass is nothing but the input must be equal to the output, right? So in order to ensure the law of conservation of mass, we have to balance the chemical equations, right? Let us take an example. When iron reacts with water, it gives Fe3O4 and hydrogen. Right? Hydrogen is zero here. So here iron is in solid state, water is in liquid state, Fe3O4 is in solid state, and this is in gaseous state. Right? So from the equation we can identify the phase of the reactant also. Right? So for balancing chemical equations, 7 steps are there given in your book. Right? But I have simplified all those things simply in a single step we can do. Right? First we write like this: what are the elements present in the equation and the left hand side and right hand side of the equation. Right? Let me write like this. So this is elements present, and this is LHS, that is left hand side, and that is RHS, that is right hand side. Okay, so we go like this. So can you list out what are the elements present here? So first is iron, right? So iron is there, and then hydrogen is there, and then oxygen is there. Only 3 elements are there, right? So now we have to count the number of elements present in the LHS and RHS. In LHS, in left hand side, 1 iron is there, 2 hydrogen is there, and 1 oxygen is there, right? In RHS, that is on right hand side, how many iron is there? Fe, 3 iron is there, 3 Fe is there, and then oxygen, here 1 oxygen, here 4 oxygen is there, and hydrogen, here 2 hydrogen, sorry, this is hydrogen. So hydrogen, this is 2 hydrogen here, and here also is 2 hydrogen. And in oxygen, here 1 oxygen, here there is 4 oxygen. Right? So to make it comply with law of conservation of mass, we have to make this as 3. So this can be multiplied by 3 to make the iron in the LHS as 3. So this can be 3. That is, you have to understand the thing. We have to change only the coefficients, not the formula. You should not write like this. Fe3. No, right? This is wrong. So 3 Fe. Here in the coefficient part only we can make the change, not the formula of the compound. Right? So now the iron is balanced on both the sides. 3 iron, 3 iron. 3 Fe, 3 Fe. Right? Next we can go for the hydrogen. Right? 2 hydrogen on this side and 2 hydrogen on that side. Right? So this is balanced. 2 hydrogen are balanced on both the sides. And oxygen, 4 oxygen on this side and only 1 oxygen on this side. So here 4 oxygen, here 1 oxygen. So here it can be multiplied by 4. Right? Again I am saying that in LHS the oxygen should be 4, and we should not write like this 4. No, H2O4 it should not be. We should not change the formula of the compound. We can only change the coefficient of the compound. Right? So we can add only 4 here. Right? Now the oxygen part is okay. That is in LHS, in RHS it is 4. But when coming to hydrogen again, so it is 8 hydrogen here and here only 2 hydrogen. So the hydrogen on LHS will be 8 now. 4 into 2 is 8 hydrogen. Right. So now we have to compensate the RHS. So what can we do? We have to make it as 8. So we should multiply by 4 again. So 4H2. Right. So this is the thing. Now this is the balance equation. Now check the correctness of the equation in both the sides. That is iron 3 on both the sides. 3 iron on both the sides. Okay. Hydrogen 8. 4 into 2 8 hydrogen. 4 into 2 8 hydrogen. Okay. And then oxygen 4. Oxygen 4 oxygen. This 4 includes this oxygen too. 4 oxygen on this side and 4 oxygen on this side. Okay. So now the equation is balanced. So once again I am repeating this. That is, first we have to write the elements. What are the elements present in the equation, and then LHS and RHS. First write the number of elements present on both the sides, LHS and RHS. And according to law of conservation of mass, we have to make some changes. Right. So this is a simple equation. Stop. Okay, we should start from the beginning again. So this is a triangle equation. As I said, we have to mention the number of LHS and RHS on both the sides, and we have to make changes according to the law of conservation of mass. So the equation will be 3Fe plus 4H2O gives Fe3O4 plus 4H2. This is the final equation. Right. Next we can go for some simple equation. This is an example given in your book. We shall go for some simple equation. Right. So here, this is magnesium plus oxygen gives magnesium oxide. Can you say whether the equation is balanced or not? Can you compare the LHS and RHS here? Yeah. The LHS, simply we can write like this. This is RHS. This is LHS. And here, elements. Simple thing. So magnesium is 1. Magnesium is 1 here. And oxygen is 2 here. Magnesium is 1 here. And oxygen is 1 here. So here the oxygen should be made 2. And again I am stressing the same point. We should not change the formula of the compound. We should not write like this. MgO2. It should not be. This is the wrong thing. We can add only the coefficient. So to make the oxygen 2 in RHS we can multiply by 2. Right. So this is 2 MgO. Now when coming to the magnesium part, again the same thing. In order to compensate RHS, in LHS there should be 2 magnesium. Again I am saying we should not write like this, Mg2. No. We should not change the formula of the compound. We can add only the coefficients. Right. So this is 2 Mg. Now check the correctness of the equation. Right. Here. Okay. This is 2. Now here RHS, it is 2 Mg here. Right. So 2 magnesium, 2 oxygen, 2 oxygen. This 2 includes this one. Right. So this is a simple thing, a simple equation. Let us go for another example. Here a simple thing. C plus O2 gives CO2. First carbon monoxide will be formed and then carbon dioxide. Can you balance this equation? How can you balance? Simply like the same thing. Here 2 oxygen is there. Here 2 oxygen is there. And here 1 oxygen, 1 carbon is there. And 1 carbon is there. So it is already balanced. If it is CO, we have to balance. If it is CO2, we will not to balance. Right.